Hi, hello. Um, Here today to discuss opportunity in biomass that has come our way as we develop our magnesium oxide mine. The base ore, the deposit itself, is magnesite, and that is then processed in a thermal process. So somewhat different than many of the discussions that have occurred today in regard to electricity. Our primary energy use in the processing of magnesite to magnesium oxide, which is our saleable product, is a thermal process. A little bit about the deposit itself. We're located in East Kootenays. The minister earlier mentioned that area, and that is the area that we happen to be in as well. As somewhat fortuitous for us since we are receiving some level of government attention, which is always nice in British Columbia. The Driftwood Creek deposit, which is the magnesium deposit, is the one that's under development. We also own a number of other magnesium deposits in the area. We've been drilling at Driftwood for a while now, and although it's not compliant, we feel that we are onto a global level deposit that could represent a long life mine. We have developed some partnerships in this. As I mentioned, we're looking at biomass as a solution, a thermal solution. So essentially what we're looking to do is the biomass coming from local sawmills to be processed into a synthetic gas, essentially a hydrogen gas, and then fed directly into our kilns as an alternative to natural gas, which would come by pipeline. We do have that option as well, so we are weighing the economics at this time, and it's not definitive that we would use the syngas solution, but it's getting close. Not quite the same as piped natural gas at the current commodities levels, price of oil, price of natural gas, but like I said, we're getting close in about the 20 to 40% range. We have some support from Eaton Energy. They're a large electrical supplier out of the UK, and Highbury is actually the company with the technology. They have developed biomass technology at the University of British Columbia, have a significant pilot plant that has been under testing for 4 or 5 years now. The department that it actually was developed with was within the forestry department, not part of electrical engineering or mining, which are big departments at the university, but really as alternative uses for forestry products. So when we talk about biomass, essentially what we're talking about in this case is waste wood from the sawmills, largely bark or strip material that occurs before the lumber is cut into 2x4s, or chips, wood ends, this waste material that is not worth a whole heck of a lot to the forestry industry, but does represent a potential for increased revenue. Forestry in British Columbia has become somewhat of a marginally profitable industry, so anything that would increase profitability in forestry has really been a focus, and that was the impetus for this syngas project. Again, Highbury being the private partner of essentially what was a public research project, originally started with grants from the government and some support from the university. Just a little bit about the Driftwood Creek project. We'll kind of move on from here. Not really here to talk about the mining opportunity. The one concept with magnesite and developing magnesium oxide production is that this is an industrial mineral. Getting things permitted, environmental, these types of things have become fairly extensive, expensive, and our decision to move into this space was largely based on near cash flow and time to market, also something we could manage to bite off. We are a junior company, and we can only handle so much and only throw so much money at a given project before we need to begin to show or at least begin to talk about near-term cash flow. So industrial mineral quarry, no significant operations at the mine site beyond the quarrying of the ore itself, and then down the hill to the processing plant located separate from the quarry itself. Again, this is largely for environmental considerations. And when I say environmental, I say more than anything for time to market, to simply be able to go into production relatively quickly, to have to rezone a rural area versus going to a pre-existing industrial site. This is the model, and the company went public about a year ago. We're now in full-blown permitting. We have expectation of comments or approval of our mining lease imminently. Our full permit will go in sometime in the next 2 to 4 months, and we expect a relatively quick decision on that. Again, knock on wood and keep our fingers crossed. But this is the type of project that appears to support a much more environmental focus in terms of mining in British Columbia. The size of the deposit, it's about a 2-kilometer strike, up to about 150 meters wide and open at depth. We've drilled up to 150 meters, and all of our drills have pretty much stopped in ore. So the key, as with all mining, tonnage and grade, and it appears we have that in terms of the deposit. The basic stuff that I've covered. One thing I would talk about here is calcination. So the process in and of itself, the thermal process, relatively simple. It would be equivalent to a cement type process. The kilns are somewhat different, but essentially you're heating at a relatively high temperature, 1,000 degrees Celsius to begin with. That produces, if you look at the bottom, number 5, the saleable product. There is caustic calcined magnesia, which is produced at 1,000 C, and then Denver magnesia, which is produced at about 1,800 C and up, and then electrofused, which is something we're not getting into at this point. It requires a very high grade of ore, which we do not feel that we could do it, but it would represent a fairly small portion of the deposit. So producing 2 separate products used in totally diverse industries. Caustic calcined magnesia is used in water treatment, fertilizer, animal feed. It's now being used in wallboard extensively in Europe and in Asia. There's been slow adaptation in North America, but with the opening of our mine, that may be an opportunity as well for very large tonnage expansion. At this time, though, that market is in its infancy in North America. A little bit of a time frame, like I talked about. Okay, harnessing biomass. So the focus here. What is actually occurring in terms of the carbon front and the environmental impact? Like I mentioned, using waste wood that would otherwise be trucked away or not saleable. The thing also to keep in mind with waste wood is you can't leave it on site. Sawdust and anything of this nature represents a fire hazard. Sawdust itself represents an explosives hazard. So the wood needs to go somewhere. The cost is relatively low, and in some ways it makes an ideal feedstock. One thing as well, number 2 there, the heat transfer. The syngas has substantially lower BTU by volume than natural gas, which inherently would be viewed as a negative in terms of getting to the higher temperature. In fact, all we need to do is increase the burner size, or the holes in the burner effectively themselves. The lower BTUs actually make for a much more even heat transfer. So there are some benefits, even though the syngas itself does contain significantly lower BTUs. A little bit about Highbury. They have patent-pending gasification technology. Like I said, they have a pilot plant up and running. So one thing that we're interested in about their technology and the company itself is that it is a relatively new company with new technology. There is a fair number of biomass solutions out there. One of the advantages of the Highbury solution is that it has very minimal creation of tar as well. It doesn't require an initial burner startup. Many biomass solutions actually require some natural gas or something to get the process, or a catalyst to get the process running. The Highbury solution, it does require electricity, but beyond that, it can run internally in terms of the syngas production. And again, in terms of what we're doing in the thermal process, it simply is creation of the syngas and then burn that syngas. There is no electrification process, no requirement for generators. So again, somewhat different than the other projects and probably 95% of what's been discussed today. Really just the focus on the thermal solution. The syngas can be certainly used to fire generators, but this is a simplification of the process, and it's why we're willing to take some risk in terms of applying a relatively new technology here. Just a little chart on the relative additional CO2 emissions by using natural gas. Okay, In British Columbia, we have a carbon tax, so this needs to be considered in terms of natural gas. It is relatively low on natural gas versus coal, but nevertheless, there still is a tax, and it needs to be factored in. So the numbers at the bottom there, $30 a ton, $50 a ton, that represents the cost of the feedstock itself, the biomass, and there is the savings in terms of the carbon tax and the offset against the carbon tax. A little bit of pros and cons in terms of where we sit in the mining process. We are relatively small. We're looking at gross surface disturbance or gross disturbance of around 250,000 tons per year. Very small compared to most projects that have been discussed today. There is an LOI, loss on ignition, of approximately 50% when the magnesite is calcined into magnesium oxide. So 250,000 tons with a little bit of waste, relatively small, but still some waste and some loss to fines in the process. Gets us about 100,000 tons per year net. This equates to about 50 million Canadian in revenue with a profit margin of approximately 50%. The point, I guess, with the small mine is that, again, back to our strategic model, which is actually putting a mine into production relatively quickly. This allows for a substantially easier permitting path than if we went for something much larger, in particular related to federal EA and other EA requirements. With industrial minerals, there are no sulfides in the ore. That's what makes it the ore, and it makes it ideal. So you have no sulfides, setting up a scenario for very minimal environmental impact, particularly with acid rock drainage, which is probably the single largest issue in BC in terms of operating, but also in terms of mine closure. As well, the energy contract and this type of relationship, some stability as long as there's feedstock in the area in terms of very little chance of increased commodities prices on the fuel side. So the feedstock, there is 6 sawmills or pulp and paper mills within the region. We see no shortage of waste wood to supply the gasification system. I think that pretty much wraps it up. Any questions? Guess I covered it.